So what we're doing now is we're looking at what a line of best fit is. And a line of best fit is to try and be representative of the pattern between two variables. So we've got bivariate data, we've got on our one axis we've got our measurement 1 and the other axis we've got measurement 2. And each of those dots represents a person or object with those two measurements. And when we're looking for the line of best fit, we're trying to identify the pattern and represent that pattern with a line. So what I've done here is, you can see I've just kind of grouped all of the data together and I've coloured it in. And so that is the pattern that I'm trying to represent with a line of best fit. So I've just now added this lovely red line. I want you to think about that line and think, is that a good line of best fit? Does that represent the data well? And what I would say to that is that that particular line of best fit does not fit well because it's not even going in the right direction. Okay, it's going in the opposite direction than the data, so that is definitely not a good fit. Let's have a look at another one now. What about this line? Is that a good line of best fit? And when I look at that, I think, well, at least it's going in the right direction. So yes, it's going the same direction as my pattern, and that's a good thing. However, it's above my pattern. It's not going through my pattern. So it's not as representative as I'd like it to be. So let's try this again. How about this one? And so what I've got now is I've got a line that goes right through the middle of that trend or that pattern of data. So I think this is a much better fit now because it's going through the centre, it's going in the right direction. And so I'm now going to just take that same line and I'm just going to draw a little thinner now, okay, to try and represent it a bit better. And what I'm going to do now is think about, how do I know whether this is the exact right slope or whether I need to change it a little bit, make it a little bit steeper or a little less steep. And what we do is we look at those points and we think, right, there are points above and below that line. So that's important for us to think, right, we need a line that goes through the middle where there's points above and below. If they were all above or all below, that'd be like the situation where we had before, where the line is above the values that we're actually interested in. So I'm just taking now, I can see I'm adding these little arrows on, and those are just finding me the difference, the distance between that line of best fit and each of the points. Okay, and what I want to do is I want to have the distances above the line and the distances below the line to be about the same. And that's how I know I've got a very good line of best fit. So the method that this is called a least squares regression line. Now, we won't actually get you to actually go and calculate this precisely, but this is the idea behind it, that when I ask you to draw a line of best fit, this is the idea that you think about when you are drawing your own line of best fit. So we want to have those distances above and below to be about the same. So what I've got, so there's all my little lines, and I'm going to take each of those lines and I'm going to start with the ones above and I'm going to add them together, and I'm putting all the lines below together, and you can see there I've got two sets of lines here. I've got the above the line values and the below the line values next to each other, and they are nearly the same size. So that tells me that my line of best fit that I drew just by hand, that's not a bad fit actually. It's not quite as good as the computer model will get, but it's actually pretty good. It's pretty close. Let's try something a little bit different. So what I've got now is I've got the line, and I've just made the line a bit steeper now. Okay, so we're going to do the same thing. We're going to look for those distances above and below the lines, and we're going to add all those together, combine them together. And what we see there is that there's a lot of points that are a long way below the data. So these points here are quite far away from that line of best fit, whereas above they're quite close. So it's not very balanced, this one. Okay, so this is not a great line of best fit. Yes, it goes in the right direction. Yes, it goes through the data, but it's a little too steep. Let's try a different one now. So let's try something a little bit less steep now, and let's see what happens here. So again, those distances above and below the line, and I'm going to add all of those up together. Oh, go back, there we go. And you'll see now you've got one big distance below the line and several little teeny distances above the line. So, but overall, there's that big distance there below and this medium-sized difference below, and that's just a bit too much because those two lines all together now don't add up. The below and the above distances aren't as close as we've had them. So this is the kind of thing you need to think about. You don't want a line that's too steep, you don't want a line that's too shallow, you want it going through the middle at around about the right gradient so that the distances above and below the line are similar. Okay, and that's that very first one here. This is a pretty good effort, this particular one, and that's what your goal is to do, is to find a line of best fit that's a pretty good effort.